It does. Hello, everyone. Very good evening. Good to meet you all finally. I hope I'm audible to you all.
Yes, sir. Hello,
Hello,
sir.
good evening.
Hello, everyone. Yeah. Basically, before we begin, a quick intro about
Good
myself. I'm
evening, sir.
good evening, Ramana. So I'm the VP of Solutioning and Technology here at Futures Technologies. I have worked in the domain of AI, NLP, as well as software development in several capacities for about a decade now. Been in the training domain as well and into R&D. And I have worked extensively with a lot of companies and come to Futures to shape the future of basically education and executive education and other such endeavors. So it's nice to meet you all. Finally, I do get updates about you guys and the problems that you guys face or how things are going on from the team. Good to see you all over here as a collective. How are things going so far, guys? Especially on the SQL and databases front. What has been your experience so far?
Sir, are you asking in terms of the lectures going on or our personal experiences?
Learning. I'm more focused about the learning. So what have you been learning so far?
We
What have you
mostly
learned so far?
covered the introductory part and some concepts regarding the ER diagram and schema. And in the last weeks, we are going through the relational algebra. We haven't started anything into past that. So maybe next week we'll start with the structured query language concepts. That is where we are at.
Okay, so you guys haven't started with any hands-on yet? Hello?
Hello?
Yeah, I can hear you now. Yes, you guys haven't started with any hands-on yet?
Not yet. This is our first class for us. Hands on.
No, sir. Actually, only theoretical classes are going on. We have not literally did anything on real time things right now. Only the theoretical part is going on.
Okay, so let me tell you a bit about, and it's interesting that you mentioned this is our first hands-on say, class. Now, the goal of these sessions is not per se to be hands-on session. These are add-on. You can consider gap-filling sessions. So to show you something extra over and beyond your curriculum, maybe to show you industrial use cases, applications of concepts you have learned, to do some complex exercises, and to see some interesting stuff. Of course, whenever there will be any doubts, any gaps that you feel that have been left in your regular training, we can always take that up and get them clarified. But just to set the expectations right, this isn't the case that that is completely a different track and this is a different track, hands-on and theory, no, not as such. I mean, we do have to understand different professors have their own approaches. Some are more theoretical, some are less theoretical. I can understand why he's taking more of a theory-based approach, especially in databases history because it's fairly conceptual if you have to at least form your base. But we'll try to also see some interesting applications of the same. We'll try to see from the point of view of a data engineer or a data analyst or data scientist what all things you should know in order to be able to apply the stuff that you have been learning. Right. So, you guys have mentioned the last topic that was taught in the session, just the last topic.
Relational algebra.
Can't
Relational algebra, sir.
hear you guys.
Calculus.
Yeah,
Come again?
relational algebra, sir. Basically, um, I am I audible to you?
Yes, can hear you now. Can you repeat, please?
Yeah,
Yes.
it's relational algebra.
Relational algebra. Have you guys been taught about referential integrity or primary keys that for a
Not
concept?
yet, not yet as per like deep understanding.
Okay, okay. So we'll do one thing. We'll take a very small but interesting topic, and I'll also probably show you some things you might have to install at least before the next session. We'll try to do this once every 2 weeks at least, so that you have some conceptual background. And I'll point you out to a few interesting places where you can also practice hands-on parallelly. So I maintain a repo and have built it over the years where you guys can get some actual industrial hands-on, not just exercises. Those are different from actually problems you will be solving in the industry. So, first of all, Let me share my screen and show you the whiteboard. Do let me know, guys, whenever you can see it on your screen. Yep. Are you guys able to see the whiteboard on your screen?
Yes, sir. Yes, sir, we can.
Okay, thank you for that confirmation. So, yes, guys, as I was saying, so we are studying relational databases. You know, databases are of two types, right? Relational and non-relational. Why are relational databases called so? Can anyone tell me?
Sir, because basically they are like a tabular format and like there is a relationship between each, like has relationship is relationship.
Has a relationship, as in?
Uh, like sir, in ER diagram as we saw, a student has a course, so it is a relationship between a student and a course table, basically.
Mm,
I may
okay.
be wrong. Please correct me if I'm.
So if I create a database, okay, and you know how we symbolically represent database as a collection of CD drives, right? That is the traditional symbol. So we would go with a cylinder-like representation. So let's say, and pardon my drawing, this aspect ratio is a bit off for my writing pad. So if we are to represent this as a DB, and a database contains multiple tables, right? So there can be table 1, table 2, table 3, so on. Okay, so let's say there are two tables. If I create two tables in the database and I don't establish any relationship between them, just two standalone tables, is it not a relational database? Let's say I have two tables, okay, two different tables. One is three columns, one is two columns, and I do not establish any relationship between them. Does that mean this isn't a relational database? Because going by your definition,
No,
this is.
sir. It will be a relational database. So sorry, I missed something.
Hmm.
It's a
Oh.
relational database only.
Correct.
Uh-huh.
The tables, whether we give the relation or not, but they are relational. The database is relational only. But
Yeah.
we establish the relationship by declaring the primary key of one
That
table.
we all know. We'll
With
come to that. The question was very simple. The question was initially, why are relational databases called so? Let's stick to that.
Sir, I think relational databases are very tightly coupled and have a strict schema.
I can alter table and add a column to this or remove a column altogether, can't I?
Yes, you can, but if you break the schema, then you have to break it in a lot of places. You can always add a column whenever you want, but if some column has some relationship with some other column, you cannot
Hmm.
delete.
I can. I can remove the relationships, alter table, remove constraint, and then do that. Everything is doable.
But that is restricted, right? Like if you can do it, then you might cause some
Might
problem.
cause if I delete the C drive content, I might crash my system, but that doesn't make my system. Windows system is not defined by existence of C drive, right? It will lead to that. That's a different thing, but can't be a reason why relational database or bases are called so. What we are trying to understand is a very, very fundamental thing. The answer is actually very simple. Once I tell you, it is part of it is actually true. What was mentioned in the first answer, that you can form relations between tables or entities, as they are called, on a modeling or abstract level. So these can be referred to as tables when they are actually existing, or in conceptual terms, it can be entities, and you can have relations between different attributes of an entity, primary key, foreign key, primary key relationship, essentially, and some other type, some indirect relationships as well. That's one of the reasons, but that came later on. The reason relational databases are called so is because of the word relation. And many people think of this reason when you are asked that you can have relations between tables. Yes, true. But do you know that another name for table is also called relation? In fact, when it was first concept envisioned as a paper, how old do you think SQL is? Any guesses, guys? Like C programming around 1970s, 80s, uh, Windows around 1980s. So how old do you think SQL is?
60 years.
More than that. In white paper, as a paper, it was existing in the 1930s. Now, it took a lot of hardware and the first computer systems and a lot more mathematics to be evolved to have a proper manifestation of it around 1950s. Then it was first implemented somewhere around 1960s or 70s. I'm probably a bit foggy on this. Then it has been in use ever since, the programming concept of programming has been in use altogether. So
Sorry to disturb you. Why it is called as relational means, see, each row is a tuple. Tuple means combining the elements with a particular basing on a certain rule. We call it as a tuple.
uh,
Uh, Ordered pair is one tuple where you have only two elements. These two elements are related. Like if we say y equals to 2x, so set of all x such that y equals to 2x, if we say for every x there will be 2x, so twice of x will be y. So like this, it is if there are three elements x, y, and z, then these three are interrelated. Like if you take the three-dimensional geometry, 3 comma 2 comma 1, if we say, so along x-axis, it is the point is along 3 units away from the origin. Then along y-axis, along the z-axis. So like this, the every element in the entity is itself is related to themselves. So that is what is the relation actually. So that is why maybe basing on that, this databases maybe would have named as a relational databases, because every row will represent as a tuple, and a tuple is a relation.
Tuple isn't a relation. You were almost right about the entirety of the thing, and I like this train of thought. But a tuple isn't called a relation. The whole table is referred to as a relation. The line of thought is correct, but it's much more simpler than that. No need to dive into mathematics. It's a relation between row and the columns. For example, every row will constitute values for example, this table, let's say, is 2 rows. And the columns, I will give them a name, ID, name, and let's say age. And the name of the table is, let's say, persons or users table. So we have user ID, we have user's name and user's age. So one and name is, let's say, ABC, age is, let's say, 30. Okay. So each row will have values for each of the attributes. Columns are also known as attributes, right? Or fields. Columns or attributes. I'm writing it TR, or fields. So each row will have to define the values for each of the attributes present in the table. Therefore, the tuples are related to the attributes, and therefore the whole thing is known as a relation. So a relation is the collection of all, you can say, columns and rows of a table, and that's why it is referred to as a relation. The early name for table came to be known as much later because of simplicity. It was actually relation, and that hence the term relational database, because the database actually contains relations. Relations are nothing but tables themselves. I hope this is clear now.
Yeah.
Yes, sir.
So one question I have.
Yeah.
Pardon my ignorance, but yeah, it's a little, it's a confusion. So while we were studying, we studied DBMS versus RDBMS also.
Mm-hmm.
Now, if I go by that definition, it means DBMS is something which RDMS is not, and RDBMS is
Not
again.
really.
So if I go by that definition I'm just talking about, so this means, so what I used to understand is, in relational or RDBMS, it gives you a flexibility that you break the tables into, like a normalization, normalization form, right? You interrelate all those tables so that your searching and those criteria become easy and you have a proper normalized structure, right?
Mm-hmm.
Now, if I go by this definition, that relation means it's a relationship between rows and columns. So going by that definition, a DBMS, what would this DBMS be then in that case?
I
Because
just represented it as a diagram of superset and subset. DBMS is a superset of RDBMS. all other kinds of databases, be it your wide column format like Cassandra or document-oriented databases like MongoDB. They are also database management system, but they are not relational because in MongoDB you have documents, you don't have relations or tables. In Cassandra you have wide columns, you don't have relations or tables. They are still database management systems, just not relational databases, a database management system. Make sense? So this outer layer or this uh, part will contain MongoDB, Cassandra. But there are several NoSQL databases. And in fact, no two of them would be much alike also to each other. They are fundamentally different as well. Any database which is not relational is simply non-relational database. That's the simplest definition. And all relational database management systems, however, they share a common property that all of them will have tables. All of those databases will support tables. You take MySQL, you take Postgres, you take SQL Server, you take MariaDB, you take anything. They will all support tables. That's one common factor between all relational database management system. Why? Because tables are nothing but relations. If tables don't exist, the letter R doesn't come in DBMS. Make sense?
Yes, sir. So this means, sir, if I've not worked on the other DBs other than these simple SQL or MySQL types of databases.
Mhm.
So this means, sir, if I look at MongoDB now, they don't have that kind of a structure like row and
No,
column.
no, definitely not. It's entirely different. In fact, very, very different.
Okay, okay,
Uh,
fine, sir. It's clarified. Thank you.
yeah. We will see if time
Sir,
permits. Maybe
sorry
in,
for
yeah.
yes, sorry for this. Sir, can you like once again tell about this RDB, please?
What specifically do I have to repeat?
No. Like I was a bit confused. Like you were telling the term relation, right? You were explaining it, right?
Quite
So
simply, tables are called relations. That's why the word relational databases, because the database contains tables. One database can contain one or more than one tables. That is the basis of data storage in relational database management systems. Clear?
yeah, okay.
Also, adding to that, you can always say that we can also have attributes of different tables related to each other, like the relations you mentioned. That is also one more contributing factor. Yeah. Yes, Ramana, I see your hand raised.
Yeah. Sir, now MongoDB and all, these are the recent developments of the databases. But
Hmm.
when it has started, uh,
Hmm.
like before SQL, what are the DMS like where the relations are not existing?
I don't exactly remember the names, but there were a couple. In fact, earlier, when the concept of SQL came into being, traditional file systems also fall under the category of DBMS. It's database management system. You are storing data in the form of files. In fact, fun fact,
Yeah.
all our DBMS internally have file systems because your data ultimately is getting stored in folders and files only. It's the RDBMS or SQL query language is a layer on top of that. There is a query engine which lets you uh, interact with those files as if they are in a table. Internally, on a hardware level, everything is file at the end of the day, files and folders. So you are just interacting with them with a bunch of rules in place in the form of that database server, which is letting you do that. But normal file systems fell into DBMS, let's say, for example, and RDBMS were specialized servers which let you interact with the file systems with the help of SQL language. So that's a easy way of understanding.
Sir, when the file system, at the end of the day, as you said, it is the file system.
Uh,
Why this RDBMS has got that much of peculiarity and the fame?
Because of the SQL query language and a lot of optimizations that go under the hood, like B star tree, B tree, which do indexing and a lot of other things. File system copied, in fact, indexing from RDBMS. And RDBMS is generally good to play around with structured data. In file
Yeah.
systems, you don't have any structures other than the name of the files and maybe putting together related files into folders. And that is also tedious, requires, think about it. If you want to find a file, simple operation, you go to a folder, let's say this PC, you have forgotten where you have kept a file called, let's say, mypasswords.txt, and you have to find it. You inadvertently don't think that you do not have the search bar. What should you do? You will open each and every folder one by one. It's a linear search, right? Go deep backtracking kind of algorithm until you find the folder which contains that file, which is not really effective. With SQL, if you have the table name, and if you know what data you want to extract, and then think that from that file you need only one website's password. So you will have to open that file, read all of the content till you find. But in SQL, if you know the ID of that row, you can find it. The query language itself was that powerful that it led to a lot of CRUD operations in a more effective manner than file systems. This is the reason they became popular.
Okay, but nowadays again the DBMS, the from the social media or so whatever we take, those are all the raw data type kind of things. So again they got the vital role to play. So that is why
Present.
all these AI and all uh, uh, came into the picture on DBMS. So now
Didn't get
the
this one.
RDBMS is going to fade.
RDBMS is in fact becoming more popular. MongoDB and all, you can see the popularity charts became
Yeah,
popular
yeah.
for about 3-4 years. Then quickly people realized the problems with non-relational databases. There are niche areas of applications, and then again to discuss about that is entirely then going into non-relational databases, understanding what are their strengths, their weaknesses. Each one has a specific strength and many weaknesses. So we'll have to take them case by case, one by one, understand where they are used, where they can't use, how they are different. That's a separate discussion altogether. We'll have it probably later once we are done with relational databases. Just know that they aren't that effective because of two main reasons. None of the non-relational databases guarantee you ACID properties. We will come to that. We'll understand why relational databases have become so popular. ACID properties is one of the first and most important one. And second is none of them can give you the sort of structured approach towards data out of the box that relational databases can. They were adopted because they were flexible, but then people realized that at scale you need structure more than flexibility. So then again, relational databases have started becoming more popular, specifically Postgres because of its open source nature. Earlier, MySQL was very popular, but then Oracle acquired it and made it semi-closed source, you can say. They still maintain an open source version, but not full capabilities. So then Postgres
Okay.
became the popular option in relational.
Sir, nowadays Oracle is not there, no? Is Oracle there still, the company?
Oracle is one of the biggest companies in tech still. They own Java, they own MySQL, they own their own Oracle database. In terms of revenue, they are one of the top 10 tech companies. It's still there. Just because you don't, as a consumer, use Oracle doesn't mean they have faded away. Just like IBM, one of the largest manufacturers of cloud data software still, and one of the largest in terms of revenue. But we don't see IBM laptops a lot.
Yeah.
Doesn't mean they are not relevant. They've switched their business domains. Oracle is still very much popular and very much relevant.
Okay, okay, okay. Sorry, sir. Sir, I am not from IT background, or so that's why I'm asking
Oh,
these
it's
many
good that you
questions.
are asking. I like this inquisitiveness. In the previous batch, this was missing. I like that you have a tendency to know, and that always leads to more discussion outside of the curriculum.
Yeah. Okay, okay.
Okay.
Sir, now SQL has been changed considerably, or the same SQL which used to be there maybe 15, 20 years back, the same kind of queries.
A very
Uh,
good question and an important one. Why I will tell you. And I was going to lay this as the premise for our learning. I want everyone to understand. There is something called core SQL. SQL is, let's say, we all know it is structured query language. But in fact, SQL is not owned by anyone. It is a specification. Okay, it is a specification. Think of it like this, like Android, Core Android. Okay, Core Android is opened by Google, but almost all manufacturers put a skin on top of it. Samsung puts one UI, Realme puts Realme UI. Different manufacturers have their own skin on top of it, right? Core Android, however, is the same for everyone. Every single Android mobile phone will have the same Core Android, but it doesn't mean you will interact with Core Android directly. You will interact with a skin on top of that. Similarly, Core SQL is same for all vendors. Vendors means these companies like Oracle, MySQL, you have Postgres, SQL Server. Core SQL part is the same for everyone. So whenever we will learn SQL as well, certain commands, in fact, most of the commands will remain same. Even if you are using Oracle, those commands will run. Even if you are using Postgres, those same commands will run. Even if you are using MySQL, the same commands will run. Example will be where clause, select statement, all the basic commands that we know in SQL, those are almost same for all vendors. That is core SQL because it is a specification. SQL is a specification. Many companies come together and they have like they pass the specification incrementally, it is improved year on year. But mostly it is one of the languages which has remained the same over all of these decades. Core SQL hasn't been changed much. In fact, nothing has been removed from Core SQL. Only few things have been added over the years. Core SQL very much is unchanged even till date. So basic SQL, whatever we will learn, even if you apply it to a database server of 2001, same query will run over there. But the fun part is all of the real world queries you will run, the complex queries you will run, they can't just work with core SQL like fragments. They need layer things on top of that. For example, I have a table. I order the table by, let's say, age, and I want people with the three highest age. So I will use in MySQL, I will use limit keyword, limit three. Limit is not core SQL. If you take the same query, run it in Postgres or run it in SQL Server, the same query won't work. In SQL Server, instead, you have to use the word top three. Same functionality is available because they are all competing with each other. At the end of the day, they are all competitors. So you will have the same functionality, but the keyword will be different. Because this is not core SQL, they're free to implement it in any way they want. So they will not have the same keyword. And they knowingly do that because they don't want interoperability. They want to lock you into their vendor system. If all of them start following the same pattern, then it will be very easy for you to switch based on cost tomorrow. They don't want that. So they knowingly keep certain things different. And then there are internal optimizations of different vendors. Postgres is optimal in or better in some activities. Oracle is better for certain other activities. Maybe the admin panel of Oracle is more powerful. The replication of Postgres is more powerful. All of those things. Like pSQL is better slightly when you are working with programmatic approach to SQL. Postgres also provides you an alternative, but it's not as good. MySQL doesn't have an alternative. Different small weaknesses and strengths. But for the most part, 90% of the things you will be learning in SQL is core SQL. 90 or at least 80% of the things that you will be learning. So core SQL is the same across the board, and it has remained the same over the years. So I'll tell you whenever we learn something like limit, whenever it is different from things from core SQL, I will let you know beforehand. Uh, know that that functionality will most likely exist in other database vendors, just that its syntax or the keyword might be different. The functionality will for sure exist in other vendors as well. Just that you have to like look up the keyword or maybe read the manual to find out what is the syntax for the same. Clear, everyone?
Yes, sir.
Yes, sir.
Okay. So speaking of core SQL now, what are the types of commands in core SQL? Anyone knows?
DDL, DML.
Yes.
DCL.
So you have
Data manipulation language and yeah.
DDL, you have DML, right?
ECL.
You have another. Now, this will differ in certain textbooks. In certain textbook, DML and DQL will fall under the same bucket. Certain textbooks, it will be different. But in most of the books, having read a lot, I found that this is the best way to segregate. DQL is separate. And then you have TCL, transaction. I'll tell you about each one, transaction control language. And finally, we have DCL, which is data control language. So what is DDL? DDL stands for data
Definition.
Definition language.
correct. Okay. First, let us go through each of the full forms. Then I will tell you why it is called so. The reason I asked that question about relational databases is I wanted to check if anyone has gone through that depth. It's important to question ourselves why something is called so. People who created SQL, they named because of a specific reason. There is an interesting story behind everything. If you get to know why Java was named so, earlier it was called Oak, why it was called so, many interesting stories reveal themselves. You can't obviously know everything behind what happens behind everything, but the reason I stated that is to spark that interest in you, that you should try to dig deeper than what meets the surface. If you read 90% of the textbooks, they will tell you what is SQL, all the basic commands. The knowledge is the same across almost all textbooks, all websites, and things like that. But if you start to look a bit deeper, if you ask questions like you guys are asking here, that's a good sign, because then only you can know more than others. Otherwise, almost everyone will know all the SQL commands or what are the SQL commands, how they are used. But how will you distinguish yourself from others in terms of knowledge? That is only by being more inquisitive. So whenever we learn, like there is an approach to learning, that is, you should always know what that thing is. Like for example, DDL. What is DDL? DDL stands for data definition language. Second, what is the meaning of that? You should be able to explain it to someone who is not from tech, let's say. If you can do that, that's a good way of understanding. So for example, what is data definition language? All of these are groups of commands. So DDL, or data definition language, contains all the commands, SQL commands, which are related to defining of data containers. That is why the word definition is there. These are the keywords. Okay. These are the keywords. So all the SQL commands which are related to definition or defining of data containers, they fall under DDL. What do you mean by defining of data containers? What are the containers of data? Think about it. What holds data? A table holds data, correct?
Yes.
Database holds multiple table, so that indirectly it also holds data, correct?
Yes.
All of these things, and later on we will see other things like stored procedures, triggers, all the containers of data, basically database and tables. You can create them, you can play around with them, creating, deleting, or removing, you can say changing, anything related to containers of data. You can do them through data definition language commands. So what are some popular commands? Create table or create database, then alter table, alter database, or drop table, drop database, these kind of commands. So create, alter, drop. This is not for creating or changing or deleting data itself. No, you are not changing or deleting data with these commands. In fact, you are changing, deleting, or creating containers of data, the structures which hold data. That's why they are called data definition language. These define the containers of data. Clear? If you're able to explain it like that, anybody can get a basic sense. Then you should always be able to give an example. And the same approach or pedagogy you will follow when answering in interviews as well. Start off with the definition or one liner or two liner of what DDL is. Then you should be able to directly tell where to or give an example of it. For example, I can give an example of create table, the name of the table with the columns, right? I can write it down very simply. We'll see that later. Or alter table or drop any command. Then you should be able to tell where it is used and where it is not used, how it is different from others. That level of understanding you need to have. For example, DDL is used, like I told you, to create the containers of data. It is not used to create data itself or to query data or any other purposes. If you've understood these aspects about a concept, your understanding is complete or comprehensive, I can say. Unless you know all of these angles, I wouldn't say you have a full understanding of the concepts. And many people think and have asked also to me over the years, or even I see in this company also, many people come during interviews and, okay, can you prepare me for interviews, or how can I answer better in interviews? Trust me, there is very little you can do. Even if I give you all interview questions, even if I leak all interview questions, there is very little you can do the night before the interview. It's about how you have understood the concept that you will be able to explain it or express it. You can't really do much without that, even if I make it an open textbook interview. So focus on your understanding of the concept while you are studying it, rather than on interviews. Those things will take care of themselves. Trust me. Now, data manipulation language. What do you think these commands do? Try to understand from the English language only. Data manipulation language. So these will be set of commands which will be used to what? Take a guess, guys.
Manipulate means change the data.
Yes, manipulate data. Now, manipulating data can be either creating data or reading data or updating data or deleting data. This is CRUD. Many times you will hear in an interview also it is asked, what are CRUD operations? Okay, what are CRUD operation? CRUD stands for create, read, update, and delete. But you can ask anyone, even a BTech student in CS branch, they will tell you what is CRUD probably, but they can't. I will tell you for sure, 90% of them will make mistake. They won't know that this is creating, reading, updating, and deleting of data, not table. You take this question and ask it to anyone. If you have a relative in BTech CSE, ask them, okay, give me an example of create operation in CRUD in SQL. They will tell you create table for sure, and that's where it is wrong. Very simple, very fundamental question. But you are completely wrong if you answer it's create the answer if the answer is coming from you is create table. That's a very wrong, very silly answer even I would say, because create table doesn't create data, does it? We just discussed create table creates the structure or container of data.
Insert
Which,
statement.
yes, which command will create data in those tables? It is insert commands. Insert into and then the table name. So the answer for create command in CRUD operation is insert statement in SQL, not create table. Many people will make this mistake, most frequent mistake. Then for reading of data, this is where DQL is used actually. DQL is data query language, and there is only one command here, that is select command. It is used for reading of data. Okay, this is the only command that can read data basically. And then you have for update, there are two commands. Many people also don't know this. There is an update command in SQL, yes, but in standard SQL, and it's also there in MySQL, it is supported. There is a replace command as well. There is an update and there is a replace. Okay. Any guesses of what is the difference between update and replace?
Sir, basically
Any guess?
update will update the whole like say tuple or row, but the replace will kind of work as a patch over there. Like it will fill the particular value.
Opposite.
Oh,
You said
sorry.
the right thing. It's opposite. For example, we have a table called orders. Okay. Very simple thing I will have over here. I will have order ID and the order amount, total order amount. Nothing else. Very simple. Okay. Two orders I have. One amount is 1,000, another amount is 5,000. Okay. Now using update, I can specifically update the amount only of order ID 1. If I write update orders, set amount equal to 1,500 where ID equal to 100. If I write this command, it will just update one attribute of a particular row or a particular attribute of multiple rows also you can do that. You can update row or rows partially using update. Update can be used to completely also update. It is up to you. You can use it to update partially, and this is its most frequent use. Replace cannot be used to partially update a record. That is not even possible. Replace completely replaces the entire row. So if I use replace command to replace this with, let's say, a new row, that is possible. I can't partially replace. Understand the basic difference between update and replace? Most frequently, we'll use update. Replace is used very, very, very rarely. In fact, you can get by without even using replace in your application even once, because update does hold the capability to completely replace all the attributes also. So most frequently, you will not find replace being used, but this is a very popular interview question again. They will test the depth of your knowledge when asking about CRUD. People will think this is CRUD. You will even go to internet and find interview questions. You will find CRUD. You will not find these things over there. But good interviewers will ask you about these things. It will show how much you have actually spent or how much you have actually tried to know SQL. Everyone reads from those top 2, 3 websites, W3 schools and those other Gigs for Gigs. I will suggest about those websites. I'll give you better ones. Try to study from those. Don't study from those top 2, 3 websites, because your answer will then be almost like everyone else. And those contain very generic, limited information. You will not get good examples, proper case studies, proper explanations, I would even say. Mostly just surface level knowledge. And then D for delete. Now there is delete from. Okay. Delete from command which will delete either one or multiple records from a table. So this is data manipulation language, and I have also covered data query language. Now under transaction control language, I'll just tell you on a basic level now what they do. We will go into them separately later on. You have commit, you have rollback, you have save checkpoint or save point. Okay. Basically, these are commands related to transactions. Now, this is again a fundamental thing. Generally, NoSQL databases or no, other than RDBMS, other kinds of databases, they do not have native support for transactions. This is one more reason why SQL databases are very popular. So we must know what is a transaction then that makes SQL databases so popular. What do you guys know about transaction? What is a transaction?
Transaction means that if you are changing any data in one table, whatever the related tables are there, it should also impact according to the rules.
No, that is data integrity. That's different.
Transaction is something like if I am trying to update a particular
field. So from the start till the end, I mean, from the time I have read it and till the time I have done the update, that is called a particular transaction. So before I start and read, I um, do a begin work, and before it completes and I do an update or delete, I do a commit work. So that is particular single transaction.
Basically, so transaction can be told,
Uh,
like can be something that follows asset properties of DBMS, that is atomicity and all that.
Okay. Partially everyone is right. Not a complete.
What transaction
any
is
any
whenever
query we can.
whenever we do any some changes, okay,
Uh,
in data. So if we have to trigger the things that if we want something to happen before that and we want to check that before the commitment of that, so we can do it. And if it doesn't verify that, so we can make a rollback. In that case, that transaction will means that change will not gonna commit. In this way, we do it.
These are
If we have to
all.
verify, pre-verify, and yeah.
Yeah, let me tell you, these are all use cases of transaction that you're saying. None of you explain what is a transaction. All of these are uses of transactions. So very easy to understand, very generic but repeated example, but I'll take that is that of a bank ATM withdrawal. Let's say that's a transaction we commonly refer to in the real world, right? That you made a transaction whenever you deposited money or whenever you withdraw money, right? But that's a wrong example, I would say, to give, because it creates a false sense that transaction is just this one complete operation. No, transaction is one or more DML operations. Okay, understand it very well. One or more DML operations which is treated as one single unit. What do you understand by that? Let me show you an example. Whenever you run a command, like let's say update table, the update example that I gave you, update orders, set amount equal to 1500, where ID equal to 1. This is a simple single operation. This single operation also is by default a transaction. Know that in SQL databases, by default, every single operation that you run is a transaction of its own. By default. That is the default nature of SQL. Whenever you run any command, DML command, that's a transaction by default. So every transaction is by default how many operations? One operation. But you can override that. Every transaction by default is one DML operation. But you can override that. There are steps. We will see this also practically, but I'm not going into that now because do need some fundamentals before that. Just on a conceptual level, you can disable this feature that by default every single operation is a transaction. Then you can begin manual transaction. Okay, a manual transaction can consist more than one operation. So let's say I have started manual transaction. So I'm not writing the exact keyword now. Let's understand this in the form of a flow. Start manual transaction. Within that, I ran one update statement. I ran another insert statement. I ran another update statement. Okay, three operations so far. And finally, a delete statement. Four statements I have run in this single transaction. Here I will end the transaction or commit the transaction. Commit means you are at once forcing all these four operations into the table. Okay. Whenever you do this, okay, it will treat all four things as one unit. So what is the meaning of this, or what is the consequence of this? We understood that, okay, it will take all four operations and do it as one single unit. But what is the meaning or implication of this? Implication is, let's consider a hypothetical situation when your operation number one passed. That update happened. You, let's say, change this to 1600. Happened. You inserted a new row. Let's also take that example. Okay. That also passed. You inserted a new row into orders table. It created a new row. Okay, done. You are trying to update this amount. Let's say you inserted the wrong amount. You are now trying to update it to 6,000, let's say. This one, for some reason, you don't know what, failed. Okay. This operation fails. So you were not able to update. Okay. This operation fails. What will happen to the transaction? What will happen to the fourth operation? Will it happen? No. And what will happen to the previous two operations that had already taken place? They will be rolled back automatically. This is the meaning of a transaction. Either all four operations go through, very, very simple once you understand. In a transaction, whenever we are talking about transaction, either all operations involved in a transaction pass or are reflected in the database, or none of them are. Even if a single operation here fails, anyone, it can be last one, it can be first one, it can be third one, second one, any one of them fails, the rest of them will also inadvertently fail. If all four of them pass, only when all four of them are reflected, that's when a transaction is persisted. That means that's when a transaction is the changes is allowed into the actual table. Only when all four of them work. If any one of them fails, the transaction is said to have failed. That means all four operations failed. So these four operations together is one unit. And popular example of this can be again in banking. Let's say when you are doing UPI transfer. Okay. Let's think about UPI transfer. So you are the sender, and then there is a receiver. Okay. So you are sending 5,000 rupees. Okay. From your account to your friend's account. Let's say they asked for money. So you are sending it. Now, what are the, let's envision this in SQL terms. What are the SQL operations that have to happen? 5,000 should be debited from your account. So which operation will be run? Which SQL CRUD operation will be run? We'll just think in terms of CRUD.
Update.
Correct. Update. First operation will be an update operation. Your account balance will be set back by 5,000 rupees. If it was 50,000, it will become 45,000. Correct. So your account balance will be updated. Update senders account balance. In order to be good at SQL, there is only one tip. If you need to be able to envision processes like this in terms of SQL CRUD operations and write them in words, you will eventually become better at writing queries, knowing more technical things. But if you are able to write the processes step by step like this, you will be very good at SQL. Update senders account balance. Then next step is
update receiver's account balance.
correct. Update receivers account balance. Increment their balance. If it was 30,000, it will become 35,000. Then some additional operations are also performed, like you receive a SMS or not whenever you send money.
Yes, sir.
Yes. So how do you receive an SMS? A entry was made into SMS table or sent message table or transactions table, you can say. If, or let's forget even SMS, if you go to your mini statement or if you go to your transactions on your mobile banking or internet banking, you are able to see this transaction or not, that you sent a money, a debit
Yes.
transaction was performed. So a
Yes, sir.
new record will be inserted into, in fact, these two things will happen parallelly. Insert a new record into transactions table of transactions table for the sender, and a new record will also be inserted for the on the transactions table for the receiver. But some SQL banking systems can do away with just one insert also. This is a scope for optimization. A simple operation would have been insert a new transaction for the sender, insert a new transaction for the receiver. But this is also where you can optimize. Instead of two operations, you can do one with both sender and receiver operation. When you are querying the data, the transaction, depending on who is querying, the sender is trying to see the transaction or the receiver, it will query intelligently. So your queries will become more complex, but your operations will become simpler. All of these are examples of things you would do practically in SQL systems. Then 4 will be, let's say I will also insert a new record into SMS table, let's say. Okay. Out of this, I'm giving you a hint. Not all 4 will be part of the transaction. Which one can be excluded? What would be a transaction again? If you have to think that if any of the operation fails, the whole transaction will fail. So which operation do you need or which operation can you exclude from the transaction, that even if it
Fourth one.
Fourth one.
Third one.
correct. Fourth one. Transaction record, if you're missing, that's a data integrity serious question on auditing.
First and
All,
second one.
no, you cannot ignore them.
Fourth one.
Fourth one.
If you ignore first and second, that's wrong, right? Let's say your account was debited, but the receiver never received. Is that a successful transaction?
Transaction
No,
state.
right? Only the fourth one can be excluded. The rest three have to be made part of a transaction. If you don't make a, what if you do not use transaction and you do them individually? Then there can be a situation, can be, there is potential. I'm not saying it will happen, but there will be a situation. Let's say money will be debited from your account, but it will never make it to the sender's receiver's account. So where is the money gone now? It will hamper data integrity. That means it is hampering one of the core ACID principles itself. Yes or no?
Yes,
Correct?
it will be rolled
Yes.
back.
So if you do not use transaction, there is a possibility for this to happen. But if you use transaction, any one of them fails, no problem. Others will be simply rolled back. You can money was debited as if it never happened. That is the beauty of transactions. And that is why SQL databases are so popular, because if you analyze properly, all popular applications, especially banking and system critical applications, they need this behavior. And no NoSQL database like MongoDB, Cassandra, none of them have been able to guarantee this transaction feature. But the beauty of SQL databases is, by default, you pick any SQL database, doesn't matter. It will give you this transaction feature for sure by default. That is the reason why SQL became so popular. One of the most important reasons is this transaction feature. But do know that it is not by default. You have to manually start a transaction, keep all of these commands within it, and then commit the transaction. So this transaction control, you have to do it manually. Many people think it is automatically built into the language. That's not the case. Yes, as a feature, it is built into the language, but by default, each operation is a transaction of its own. So that will not help you in this case. You have to keep all three of them as part of one transaction. That you have to do manually, and we will also learn later. We will see all of these begin transaction like commands, how to do it in one statement or in one transaction. Understood, everyone?
Uh, Sir, one
Yes,
question.
sir.
Sir, one question.
Yes.
Sir, in this case specifically, sir, at what point this sender, let's say the amount is deducted from sender's account, okay?
Uh,
Then the receiver receives the amount. Sir, there would be an acknowledgement, right, which sender must be receiving. Then only it is, confirming that yes.
No. That's the beauty of this system. No need for acknowledgement. If your transaction succeeded, at the end, if your transaction succeeded, you are automatically assured that all three of them happened. In SQL, if you made them a part of the transaction, if any one of them failed, other two would have also failed. That is the nature of transaction. You do not need acknowledgements. That is the beauty.
Okay, but I so basis my understanding, I may be wrong also, sir. But let's say this is bank one, that is bank two. Here they must be using something else.
Then for that, you cannot use SQL. If it is bank one, bank two, their databases will also be different, right? Then how can you make
Correct.
them part of the same transaction? Then we will involve the concept of API, HTTP protocol, REST, and all of that. That's a different discussion altogether.
Okay.
Sir, I also have one query here.
Yeah.
The four steps that you told, according to me, after the sender's account balance has been deducted, then after that there should be after that only the statement should be generated into table should be added. I'm sorry, data should be added into the sender's mini statement that it has been deducted, and then
It
it should.
doesn't matter. The all three transactions will be reflected at the same point of time only. First, they will be reflected onto a virtual table. If all of them succeed, then only they will be reflected onto the persisted into the real table. The order really doesn't matter over here.
Yeah, but sir, in case 5,000 rupees deducted and somehow it did not reach reach to the receiver, then there is a case of then refund after that, right? So in this case, sir, I don't know, I'm not sure, but will the order matter? Because again,
No, it won't matter. As I told you, let's say this happened, you are saying this failed, automatically the whole transaction will fail. This will be reverted automatically. So it's as if this deduction never happened. Got
So,
it?
sir, are we
We
talking
need
real
that
time or
particular transaction in our statement to for the future reference. I mean, we cannot just roll that back because we even need that entry that okay, it happened from the sender account, but it never went to the receiver account.
Why will it be entered into the transactions table? That is another feature called payment history if you are talking about PhonePe. If you try to send a money and if it was never sent, if it shows you on PhonePe that payment failed, If you go and print your mini statement, will you find the transaction there?
Yes, sir. We like I have
I'm
seen
talking
like
about
in
payment failed, not deducted. And this is I'm abstracting a lot of things. I understand the situations you are mentioning, money was deducted, it never reached because of the server failure. But let's say you are trying to pay and it shows you receiver server is busy or down or something, and it never payment failed, but the money did not get deducted. You will never see this deduction, but it
yes,
happened in the background. What happened was first year balance was deducted by 5,000. It tried to credit but found that this step number two could not take place. So it again credited. You could not know of that transaction. I'm talking about the background scene, not when it is actually deducted, like you would receive a minus 5,000. Got it? That's a
Sir,
network error. That's a separate thing. Okay?
sir, how you see there are 4 transactions. Now these 4 transactions, how we
No,
can
there is no four transaction. These
yeah,
are four
three
operations.
transactions.
Four
Update
operations.
servers senders account balance, receivers account balance, then insert a new record into transaction table.
Yeah.
So how we can map these transactions with CRUP, create, read, then update. So
These are
which one
all.
comes under what?
This
Maybe
is
the first
update,
one is the C, that
update.
is create.
This
Okay,
is
okay,
C.
okay.
Okay, no. These are,
Sorry.
this is I have written. This is C. Insert is C. You are creating some new data in a table. So you are creating C. Update is very easy. Update. And
Yeah,
this is
that is
also,
C.
yeah. Clear?
Sir, what
But
do we
not
call
all
each?
we got no CRUP. Only C and U got.
You all operations will
Every
not always
transaction
involve
not
CR.
necessarily should have.
No. Not at all. Not at all.
Okay.
What do we call each statement of a transaction? Is there any word given, like sentence given to
No. Operation.
operation?
Just an
Okay.
operation.
So one more question. The fourth transaction, insert a new record into SMS table.
Fourth operation.
Now, fourth operation.
Yeah. Operation.
So one, see, nowadays we are having the mobiles, then we used to have the SMS and all. But when the databases are there in the olden days, there is no as such any short messaging services. Then that time this fourth operation would have not been done.
No. Not necessary.
Okay.
So from my
Okay.
point
Thank
of
you.
view, uh,
Yes, Neha.
yeah, point one and two is the required point. I think the third point should be a kind of absurd from the receivers and senders point of view, because the
No,
balance.
here you are thinking from sender and receiver. Again, shift your perspective to a bank's point of view. From
Mhm,
a bank's point of view, where you have, let's, for the sake of this discussion, consider sender and receiver to be in the same bank.
mhm.
What all operations are necessary for the transaction to be successful? If point number three doesn't happen, it is a serious issue for the bank if transactions are not getting recorded. They'll never allow a transaction to happen if point number three is interrupted. Never think from a customer point of view. Always, when you are thinking, you will be working for the bank, not for
Yeah,
customer.
no,
If you are
and I
data, yes.
was more concentrate on the requirement. The requirement is for the always for the customers, right?
But that's a
If
different
the
thing.
requirement is fulfilled, then like we can somehow manage the third point.
No. You
Because
have
we
to.
send details to the users, right?
No, you have to manage compliances, lot of things. In fact, as a data engineer or a data analyst, this is more of your work. When you this will define whether you move up to a data governor role or not. If you are aware of compliances, security measures, this is what is your role versus someone who is a developer, let's say. They will also know how to use SQL, but they won't think about these aspects. You have to think about all the aspects. That okay,
Yeah,
from a customer point of view, one, two is done, but from a bank point of view, three is very important. In
then
fact, they
four should be in the same line, na? Then four should be also a very important
no, four is
important.
not important. Four is again a customer point of view. It doesn't matter if the SMS is not sent. SBI doesn't send you the SMS half of the time. So what? The transaction still happened, right? It's
Yeah.
okay. It doesn't send you. It's a non-critical operation. It doesn't matter if it fails or happens. They mostly will put it into a retry table. There are different mechanisms. As you move up, you will get to know. There are different mechanisms. Even if it fails, they put it into a retry table. Then from there, a scheduler runs it, takes again. Retry is sending the SMS maybe after 2 minutes or 5 minutes. That's why you sometimes receive the message after a delay. It tries 2 or 3 times. If it is not able to send because of a SMS server issue, then it simply gives up. Like it's okay, it doesn't send. Some banks have a workaround for this. If 2 or 3 times they try to send you this SMS, let's say OTP or transaction, it doesn't get sent. They will send you an email instead. So different banks have different approaches, and there are different workarounds. But that's again we are going into system design territory. From a database point of view, you have to know two things. A, from a business point of view, how or what will contribute to a transaction being successful. From a business means you have to think about security compliances and customer expectations. Security compliance is more important than in fact customer expectations, because you can be sued on the basis of that, whether it is happening or not. Customer expectations get still fine, and that's it. And then implement the same, think about steps, then know enough SQL to be able to pull that off. That's all.
Okay, thank you.
Okay, clear?
Yep.
Yes, Riyansh, you have a question?
Yeah, I got to know about the transaction, what a transaction is, but I'm just asking a question like what if the two transactions are happening all together and both are doing the changes on the same resource?
Two transactions
I mean,
can't
like
operate
in
at the
account.
same time on the same table.
Yeah, yeah.
It's impossible because of locking of tables.
It's like someone is there are two accounts and there is only 5,000 in that account, and two people tried to get it from two places. That person tried to fetch the amount in two different accounts.
Whichever transaction grabs hold of the table first will complete its whole transaction, either fail or success, whatever it is. Then only the next transaction will continue. That's how locking works.
Yeah.
So the transactions are queued also. That
Otherwise, the whole world will be
Yeah,
chaos.
yeah,
Yes,
yeah.
yes, there are
I just
Also,
wanted to
the
transactions.
understand.
data control language will have the encryption, right?
No, not encryption. Data control language will basically, it's also interesting. Basically, commands like grant, revoke. What that means is, and it is also very, very important, especially from a data administrator point of view. Let's say you have a table, okay, transactions table, right? Should a end user like me, I'm an end user of, let's say, SBI. Should I be given write permission into transactions table? Transactions table holds the transaction of every user of that bank, every customer. Should I be given a write permission into this transactions table?
Oh, sir. This can misuse it, sir. Means
Yes,
data.
exactly. A developer, while developing an application, let's say they are developing an application like Facebook, okay? Uh, or you might have noticed sometimes that in certain applications, you can only create a user from the backend, an admin user, like admin of Facebook. Can you register as an admin of Facebook? No, right? They are created internally from the backend, but you can register as a user of Facebook any point of time from any email ID. That's fine. So certain privileges are not allowed to all people. So in SQL, whenever we will also use, and I will show you this in the next session, how to create, how to install, and yes, few things you have to install is, no matter which operating system you are using, install MySQL Community Server. Okay, MySQL Community Server. Okay. I'll show you also where you can get it from. I need it to be there with you guys. Just if not anything, just download the installer and keep it. I will show you how to install because there are certain configurations I want to show to you guys. So MySQL not tutorial. You can follow this website and this website, these two for learning. No, don't follow W3 schools. It's a wasted website. Follow dev.mysql.com. This is the official documentation, or MySQL tutorial. Or as a third website, you can go for uh, Data Camp. You can go for anything from Data Camp or anything from Medium. Anything from Medium, anything from Data Camp, anything from dev.mysql, or anything from MySQL tutorial. These are reliable, good sources. Others are simply not that great. In fact, they will give you just surface level knowledge, as I told you. You can just search MySQL community server. It will take you here. Download MySQL community server. Click on this. It will give you your operating system, automatically choose a version. Now, do not download the zip file, okay? And do not download the archive file. Download the installer file. Download always the installer file. Installer will be installed into your system. Zip, you again have to extract, put it in the right path, add an environment variable, extra steps unnecessarily. So download the installer for your system. In Mac or Linux-based system, you can even look up commands to download it. Or you can look up install MySQL community server on Mac. You'll get a bunch of commands, 3, 4 commands. You can do it straight away from your terminal. So once you have it, I would suggest do not install it. Just download and keep the installer because it is around 130, 140 MB. I want it to be there. Then one of you can share your screen in the next session. I will show you how to install it and I'll explain several steps and things mentioned over there. We will understand what are users, what are roles of users, what do you mean by permissions. So if you want, you can in fact create one user in your MySQL server. Let's say create a user called user1. And to this user, you will only give read permissions. So out of the CRUD operation, they cannot perform create, update, delete. They cannot delete any rows from any table. They cannot update any table. They cannot create any new row in any table. They can only perform select queries. This also you can do. And this is in fact a very helpful thing because then users intentionally or unintentionally, anyway, they cannot get access to delete rows unknowingly. Hackers can otherwise get into your systems. So web users, they generally get this read access and limited write access. We will see that only to their personal tables, or it is only to a temporary table. From there, it is then written to the main table through scripts in the backend. So all of these steps are very important. Data control language basically defines the commands or is the set of commands like grant and revoke, which controls a creation of new users. Of course, you can create new users, more than one user for a SQL server. And then which user will have exactly what privileges or permissions to perform. By default, when you install a MySQL server, a root user gets created. The root user has all permissions, everything. But that's not the user you should be letting others use in your system. You should create specific users as per their role, grant them limited or selected permissions, and then continue from there. Clear, everyone? So for the next session, yes, as I told you, download MySQL community server. As a part of community server only, you will get MySQL Workbench. So you don't need to download it additionally. You will get it over there. The second thing that I would like you to install is dbeaver. It's a GUI for SQL. Again, community edition, you can install dbeaver. Okay. And everyone, third thing that I would want you to do is create a GitHub account if you haven't already. Create an account on github.com. I'll tell you why in the next session. Clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So if required, I will post this screenshot also in the chat. I hope you're clear on whatever we have discussed today, everyone.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right. So we'll focus more on the actual use cases of SQL, not much of theoretical things like ER diagram and all. You will practically not use it much. You will much rather know on why to use something in real world. We'll focus on that. So try to stick to the sources I've told you when you are trying to study SQL on your own. That will be helpful. And we'll also give you some good examples to tell in your interviews. All right, we can wind up over here, guys. And
Sir,
yes.
sir, I want to say something here. So actually, your course is like your teaching is very like important and like nice for us. But the problem is like the class timing that is. From next time it's around 6:30 to 7:30. And sir, honestly, sir, like after attending today's lecture, I am really not in the mood to miss any lecture. But due to my office hours and all, I do not get like I get at home at 7 p.m. daily. So I'm more likely to miss the session if it goes on 6:30 to 7:30. So I, sir, like request you if it can happen like maybe this time or
Can we do
later. It
7 to 8? Because I also have to get home after this. So 7 to 8, will it work?
Sir, honestly, sir, due to restriction of office hours, this is very tacky situation. Uh,
Sir,
sir,
at least make it 7:15 to 8:15.
Okay,
Neither
okay.
7 nor
Sure, sure. Sure,
7:30.
sure. I can try for that. Yeah.
yes, sir, yes, sir. Because yeah, again, sir, things are very much going great, and we all want to attend it for long. That's why.
Sir, because this SQL theory part is something else, and what the hands-on is something else. Without this, that will not work, and what without that, this will not work. So
Yeah, but as I told you, these are just additional sessions. You should also ask your professors to show you hands-on whenever required, because these are our attempts to give you a more holistic understanding of SQL, and this was my idea to like give you guys something extra, because I've seen gaps in industry interviews and what happens in theory. But it's not that I wouldn't suggest being relied on this, because honestly, if you ask me, 4 to 6 sessions on hands-on, I wouldn't say would cover everything under the sun in SQL. So you should ask your professors if, and do understand IIT professors have a certain temperament. So they will act according to their temperament. It's fine. Whatever doubts are remaining from there, you can always ask me. I'll clarify those, and additional hands-on we will see over here. We'll focus, because it's honestly too less to cover the breadth that SQL has. We'll focus much more on things which are not going to be covered on your curriculum, like, and things which are important, like stored procedures, stored functions, triggers. What is the importance of indexing? What is the importance of writing good creatable statement? What are the different elements of it? Differences between subqueries, joins, views, how to use views, all of that. These things I don't think will be covered in your curriculum. We'll be focusing on this. So I would still say things or hands-on related to your curriculum, you can ask in the session itself. That will be good.
Thank you, sir.
yeah, maybe our IITs are also will be taking the
But
SQL classes.
in my experience, I've seen you have to push for a bit. You have to ask them properly for examples or to give
Yeah,
some.
that because you are actually from the industry, your approach will be quite different from the academicians.
Yeah.
See, that's exposure we want. So that's why we are asking you for at least 7:15, if not 7:30.
Yeah. I'll
That's it.
do 7:15. No problem.
Thank
7:15
you,
to
sir. Thank you.
8:15
Thank
or
you.
8:30 will do it. Okay.
Thank you, sir. Thank you.
Yeah. No
Sir,
problem.
I have one more question related to tools. Like, will we get the chance to work on tools like Spark and Hive and any other tools
Most
which we?
likely during I'll have to check the curriculum, but not during first trimester. Most likely during second or third. I'm not sure which one. Most
Mhm.
likely during second, I think. Some tools are during second and some tools are during third trimester.
Basically, it depends on the trimester we will be in.
Yeah.
Okay, thanks.
All right. Thank you, everyone. Have a good day and good week ahead. I will see you probably next on next.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, everyone.
Thank you, sir.